Let's take a look at some sample problems on 2.3, set operations and Cartesian products, and we'll begin on page 65. In the first group, we're doing matching from group 1 to group 2, and what we have is a series of descriptions, and we have to match the description in part 1 with the description in part 2. So number 1 is the intersection of A and B. So A says the set of elements that are in A that are not in B. That would not be correct. B, the set of elements common to both A and B. That one's correct. So I'm going to put B. Number 2, the union of A and B. Okay, well I know A's not correct and I know B's not. Set of elements in the universal set that are not in A. That's not correct. Set of elements that in B that are not in A, that's not correct. Set of ordered pairs, union is not a set of ordered pairs. F, the set of elements that are in A or B, or in both A and B, and that one's the correct one, so the answer will be F. Number 3, the difference of A and B. So A is the set of elements in A that are not in B, and that would be correct for the difference. So that's A. Number 4, the complement of A. We've used A and B. Set of elements in the universal set that are not in A. So that's the correct description. That would be C. Number 5, the Cartesian product. There's where our ordered pairs come in. Cartesian product of A and B. So that would be E. All right. Number 6, the difference of B and A. And I think the only one we haven't used it is D, and it says the set of elements in B that are not in A. So that would be correct on that one. All right, moving on to number 10, we're given a universal set that contains the letters A through G. Y contains the letters A, B, and C. X contains A, C, E, and G. Z contains B, C, D, E, and F. So in number 10, we're to figure out what would be contained in Y intersect Z. So we're looking at Y and Z to see what they have in common. They both have B, and they both have C. So the set containing B and C. In 16, we have X complement intersect Z. Okay, first we need to figure out what X complement is. So we're comparing X to the universal set. X has A, it does not have B. It has C, it does not have D. It has E, it does not have F, and it has G. So now we want to form the intersection of set X complement with Z. B, D, and F. B, D, and F are in both. So that would be our answer. Circle it since it's not the bottom thing. All right, number 20. And I also worked this on another page again because I had, first of all, I had pen problems and I thought I had saved the file up to that point, and then the file wasn't saved. So I'm having to redo the first part of it, and so you'll see part of it, and I'll talk about pen problems at the beginning of the next video, so you can just kind of fast forward through that. Y complement was everything in Y that's not everything in Y that's everything in the universal set that's not in Y. You can tell I'm getting tired. D, E, F, and G. And we want to form the union of Y complement with X complement. So our X complement's up here, Y complement's here. We need B, D, E, F, and G. Okay, so now we want to find the union of that set with set Z, complements on the inside. So as I look at this set now and compare it to set Z, I want B, C, D, E, F, and G in the union. Okay, so here's my final answer on that one. And I want to do one more. Y minus X. That's the set of all elements found in Y but that are not in X. So Y contains A, B, and C. X contains A and C. So the only thing found in Y not found in X would be B.